It's 7 on the dot. Let's wait a couple more minutes, like say 7:03. Yeah. A lot of people have registered and a lot of people are coming. So just in the last 30 seconds, we had 25% more attendance. So let's give it a couple more minutes for people to show up, and then we'll be on the way. Folks, welcome. This is Soham. We were just waiting for you. Please make yourself comfortable and look forward to have fun in the session. As expected, attendance has doubled in the last 2 minutes. Let's wait a little bit more, and then we will get going. Andrew, am I audible to you? I'm guessing I am.
Yep, you're good to go.
Perfecto. All right. Good seeing you, Andrew. Thank you for doing this. Appreciate it.
Yeah, of course.
And we'll get going in just a couple of minutes. I'm being asked if that's a virtual background or is it a real background. I wish there was a poll. I want to see what people think. Is it virtual or is it real? I'm not going to move my hands. Otherwise, you'll figure it out. I'm not going to pick up anything next to me. Otherwise, you'll figure it out. Maybe guess for the next minute or so while people are still coming in. I confirmed it. Come on. How did I confirm it? I said I'm not going to move my hands or pick up anything. I mean, move my hands was virtual. Pick up was for physical. So I didn't confirm or deny either of those. And folks, those who just joined, we were just waiting for you. Got a lot of interest in the session, and people are just coming in and in, which is good. It's virtual, okay? So there's some people think it's virtual. All right, let's get going. It is 7:05 Pacific on the dot. It is 10:05 Eastern, and and there are people from some other time zones as well. It is a bit late in some of the other time zones. So let's get going. Again, folks, my name is Soham. I'm one of the 2 founders of Interview Kickstart. Some of you know, some of you may not. Interview Kickstart does 2 specific things. On one side, it has courses to learn machine learning. So you start from Python all the way to designing distributed large models. Could be language models, could be models for generative AI, whichever it is. So you learn the whole thing, the whole shebang within a year, 9 months to be more precise. And we also now have courses, if you don't want to do all the math and design the models, but you want to make systems like, say, recommender systems and such using existing machine learning systems, machine learning models. So those courses also we have started to offer. On the other hand, Interview Kickstart does interview training, interview preparation. So you could be any type of engineer or somewhere in tech, backend, frontend, full stack, embedded, iOS, Android, or you could be any of the managers, PM, EM, TPM. So those are the courses we run. Every week we have this session we call Upsides session. We generally run it at about 6 p.m. or 7 p.m. or 8 p.m. Pacific, somewhere in that window. And we invite a guest or we discuss some current market trends that we are seeing. Right? So sometimes Ryan, my co-founder, and I jam on the market trends, and sometimes we invite experts like Andrew to go through different technical aspects. Sometimes career-related things we discuss, but generally cutting-edge things that we discuss as part of just giving back to the community. And we do a few things, more than a few things, on the community side as well. So this is one of the sessions. Without further ado, I will let Andrew take over. He is going to teach us all how to do this Quora answer ranking system. Andrew, please take it away. Please do introduce yourself for a couple of minutes to everybody, and please take away the stage. Folks, thank you all for coming.
Awesome.
Andrew, please.
Yep, thank you, Sam. Really appreciate it. So I'll go ahead. I'll share my screen, and then I can go ahead and introduce myself, and we can go ahead and get started. So, thank you all so much for giving me the time to chat with everyone today. It's gonna be a joy. It's gonna be a fun little session. Go ahead and start my slideshow. So first off, can everyone see that? Everyone can see the initial slide there. I think I have my chat pulled up, so I think we should be good to go.
Yep.
Cool. Awesome. Fantastic. All righty, everyone. So let me go ahead and I'll go ahead and introduce myself first. Like Tom said, my name is Andrew Castillo. I'm currently a data scientist at a company called CoverMyMeds. If you're not familiar with CoverMyMeds, we are kind of like a subsidiary of McKesson. So McKesson is a very large healthcare technology company. They do a bunch of different things. And CoverMyMeds is more like in the pharmaceutical space. So the majority of my time that I've been here at CoverMyMeds now for about 2.5 years. Primarily in the healthcare space. I do a bunch of different things, primarily around like NLP related kind of tasks, unsupervised techniques, and anomaly detection. Those have been my jam for the better part of 2.5 years, and it's been tons of fun. I love NLP. It's always a great time to talk about it. And a lot of CoverMyMeds, what we do is around the prior authorization process, which if you're interested, maybe we can talk about it more later, but pretty much just trying to get medications to people in a more efficient way. So a lot of what I've done is try and predict whether, a prior authorization is needed, whether it's going to be approved, what kind of factors influence the outcome of prior authorizations, things like that. And pretty much building out models, statistical models, to be able to do that. So, but even before that, before I was a data scientist, I did my PhD in mathematics at Ohio State. Always loved math. I've always had a joy for it. And at Ohio State, I was a teacher for 5 years. So I really love teaching. It's kind of why it's awesome to be here at Interview Kickstart. I've been here since about March. I've taught a bunch of statistics, stat classes, and courses involving like neural nets and things like that. It's truly a joy to get to chat with everyone about these cool things. Kind of how I get into the field. I love helping people. They help other people online because when I got into the field, I had to depend on people to help me as well. So always a joy to get to talk to everyone. So that's a little intro on me. If you're interested, maybe we can talk about it more later. But I know we're kind of all here to kind of talk about this anchor ranking procedure at Quora, right? So the big thing, right, that we want to try and do today is kind of give you like a 1,000-foot view of kind of what goes into this, right? And what's really cool about this kind of procedure is that you see it in other places, right? So you might see it in other kind of social media aspects, right? Like Reddit or Instagram, Twitter, things like that. The way these kind of update feed happens in the kind of like social media setting, right? Which is really, really cool. And I'm hoping to kind of show y'all, how these things are used in industry. If you're maybe looking at trying to get into the field, what kind of goes into this, right? Because when you start looking at real life data, like, man, it gets crazy. Things get big, things get fast. You got to scale things. You got to do things on a whim. And companies like Quora do a really good job of being able to do that. So, kind of, we first want to talk about the this answer ranking procedure, right? What kind of goes into it, and then some other ML use cases that can happen at Quora and why it's almost like needed in certain aspects. So, that will be really cool. Okay. All right, and if you have any questions too, feel free to put them in the Q&A. I'll have them all off to the side here. I can always take some questions. Always happy to chat. Try and not take up too much time. So let's go ahead and get started. So let's kind of look at answer ranking at Quora. Okay. So if you're not familiar with Quora, right, the vision statement is essentially, I almost think about Quora as almost like a hybrid of almost like Reddit and Stack Overflow. Right, like they answer tons of questions, right? They answer tons of questions. They can be coding questions, they can be math related questions, they can be politics, economics. It's a bunch of different things, and there's a bunch of really, really intelligent people answering those questions, right? And their vision statement is to kind of grow and share like the world's knowledge, right? There's a bunch of different topics that kind of go into it. And because of that, right, there's 100 million or hundreds of millions unique questions at this point, questions and answers, and there's just a bunch of different topics. Okay, like I said, it goes from math to politics, economics, dancing, whatever you want. It's pretty much up there, and they need to be able to rank order this stuff in a really efficient way. So how do you do that, right? So because of that, machine learning is an important part of what they do. So if you aren't too familiar with Quora, here's kind of what we're looking at, right? So like they say, what are the best Caltrain hacks, or how did Ashton Kutcher prepare for his role as Steve Jobs, right? Funny enough, I was just looking at this. There's just some math related things I was looking at previously. So like, Quora does come up as a Google search engine quite often. Maybe some of us have experienced it, right? And oftentimes you have people responding to them, right? So you may have people who are like going to be experts, and they are trying to go ahead and give their answers there. You might even have Ashton Kutcher respond to this kind of thing, right? So you get a bunch of different question answers that can happen. And the big thing, right, we think about Quora is, which answers do you actually want to populate towards the top, right? Again, this is kind of a similar thing with like Reddit, right? Or other kind of social media kind of platforms is, here's a question that someone posed on the internet. Again, this is kind of wide open. All you really need is a Google account, right? You can log in and, anybody can post on this. So you want to try and say, okay, well, here's a question. Well, which answer is going to be most relevant towards answering this question? Okay, hence the answer ranking. So the answer ranking, kind of like what I talked about here, right? So kind of the same question posed here, but which question or which answer, excuse me, do we actually want to kind of propagate towards the top, right? So, we have maybe someone here who is apparently the CEO of Alien AI, right? And maybe someone here who is maybe not necessarily as an expert as this person. So, maybe do we want to almost rank this answer higher than this one? Or do we want to maybe rank this one higher than this one? Maybe what are they actually saying here? It's all context dependent, right? The coherentness of the answers as well. Also something we have to take into consideration, right? So all these different things Quora kind of has to think about, right? We have to think about maybe the topic expertise of the person answering the question, the coherentness of it. Does it even make sense? Is it relevant? All the different things you kind of have to consider when trying to figure out which answers to actually rank, right? Maybe the upvotes, right? Maybe a number of upvotes are really, really good, right? Now, the thing is, number of upvotes, that doesn't always correlate to the highest ranking answer, right? Because sometimes people will upvote a funny answer, right? Not necessarily the most relevant answer. So you have to kind of keep all these different things in mind, and we're gonna kind of talk those different use cases as we kind of go through this, okay? But hopefully, it's kind of, if you're not too familiar with it, it's kind of the idea of what we're doing there, okay? We have a question, we want to figure out which answer is most relevant, especially if there's more than one, obviously. Okay, so just some considerations, right? What considerations do we actually care about? So first of all, we care about relevance, right? What would the user even be interested in reading the answer, right? Would the user be able to answer the question? Is it of high quality, right? Like I said, is it coherent? Does it make sense? Is the person an expert in that topic? Kind of like we talked about already. Is this question, is it asked a lot, right? Like in machine learning, right? Like, I don't know, what do the coefficients of logistic regression mean? That happens. That's a question that gets asked a lot, right? Or what is the bias variance trade-off, right? These kind of questions that happen a lot. What's the demand for them, right? So do lots of people want to get answers to this question? That's always a big thing. Or is it a very nuanced thing, right? We have Quora and other social media platforms kind of have to take this into consideration. Okay. So different considerations to keep in mind. So the problem definition, right? So the big thing you want to think about is you want to try and rank answers, right? According to their quality, right? Now, what does quality mean? So the kind of a baseline approach is going to be to kind of look like upvotes and downvotes, right? I think like Reddit does this a lot, right? Where you kind of look at, okay, what answer is getting upvoted the most and tends to propagate usually, or downvotes, right? If there's downvotes, it gets towards the top. So you really have to filter it or it gets deleted. But the thing is, you have to keep in mind with this kind of baseline attempt, and this is kind of what you think about in data science, right? Is that, with this baseline, popular answers aren't always correct, especially whenever there's a human element involved in this thing, right? You have to account for that human element. And oftentimes as humans, we always think like, oh, maybe jokes are funny, so we're going to upvote it, right? Or, maybe person who actually really did rank it, or who actually did give a coherent answer, maybe they just didn't get their answer read as much, right? Because everyone kind of saw the top few that were really, really good, right? It's kind of like this rich get richer kind of scheme, where the funny ones, or maybe the ones that bring most humor, kind of get upvoted. So you kind of have to filter through that noise to actually understand, okay, which answer really should go to the top, right? So, even if this answer is really, really popular, is there one below it that's really, really good? So how do you actually do that? Okay, so you kind of have this baseline of upvotes and downvotes, but what other things should we be kind of taking into consideration? So there's different things you want to try and think about here, right? So there's answers, there's questions, and the author info, right? Those are all basic things we got to think about, right? Again, is the author and even an expert on the topic? What answers are they given? Is the answer relevant to the question? Things like that. How do we define quality, right? Like, what does that actually mean? Okay. And here's another big thing, which I'll talk about in a little bit, right? But inference, right? Inference needs to be made online whenever a new answer is posted, right? So as soon as these new answers get put, right, we got to rank order. If a new answer gets in, we got to rank order, right? We got to start immediately doing that, right? This is kind of a thing that a lot of internet companies deal with, right? There's not just a one-time train aspect, and then you're making predictions in real time. Well, you almost have to train and then almost like retrain in some way in real time to try and upvote or move things around, right? Think about like Instagram, right? If you go on your Instagram story, right? Facebook, if you like a story, if you share a story, if you share an image, whatever you're doing on social media, well, Facebook wants to show you more of those reels. If you like pictures of cats, I don't know, and you start sharing a lot of those cats, well, Facebook wants you on the app, right? So they're going to show you more pictures of cats, but they have to update that in real time. If they wait a week to update that, well, they may not keep you on the app, right? It's kind of the same with Quora, right? They need to try and show you those answers, and eventually update your feed, which we'll talk about later on. So we need to kind of do inference in real time. And the big thing is to personalize those results, right? Because again, I have interest in dogs, you may have interest in moose, right? So how does Quora kind of maybe separate that, and make it more individual for the actual person? So different things to kind of consider. And again, to kind of consider, what's going on with Quora, right? There's 500 million users. There's a ton of question answers, right? Over 90 million questions, 10 million answers. It's 120 gigs of just text storage. The number of answers per answer question is like 3. Number of new answers per day is about 10,000, right? And you want to try and make this latency of new ordering really, really short, right? Under 200 milliseconds. So it has to be really, really fast. And again, why is important? Because it influences the modeling choices, right? If you want to build a model to get you under this latency speed, that's going to depend on the model that you choose. And we'll kind of talk about later, and we'll talk about that later on. So there's certain things to kind of consider when you're putting this at scale, right? Because again, remember, it's an internet company, tons of users, tons of data, and we have to be able to account for all those things. So, and again, I'm kind of setting up the stage, so we'll talk about later on. All right, so what does it mean for quality, right? Kind of talk about this whole quality idea. What does this actually mean? Okay, so like I talked about before, right? What does this baseline actually mean, right? So again, upvote means different things to different people, right? Funny, correct, useful, right? It kind of just depends on what you're thinking about. Right? If you're on Quora, to the best of my knowledge, I don't think you can actually like select the answer that you think is most relevant as the person who posted the question. You can on Stack Overflow, right? So it's kind of like up to them kind of define it. So what is quality, right? Quality is going to be the answer to the question, right? Is it actually correct? Right? Like, you know, if you give me a basic answer and it's not correct, like, why are we going to propagate that towards the top, right? Another thing, is it clear and easy to read, right? That's another big thing, right? Does it actually make sense, right? Is it simple? You know, is it not just one big long run-on sentence, right? There's other kind of like semantic, syntactic things we have to think about when we're trying to think about quality, right? Is there evidence to support it, right? That's going to be another big thing. Is there evidence to support that that whatever they're answering the question with? Okay, if they're going to say something about the coefficients of logistic regression, we want to make sure that they actually back it up with just something besides a one sentence answer, right? Like why is this happening? You know, things like that. All these things do matter in that kind of context, right? And another big thing is going to be to demonstrate credibility, right? So are you actually an expert, right? How does that actually work out? How can Quora kind of fact check that in some sense, right? So a bunch of different things to kind of consider and that we want to try and keep in mind. Okay, this is kind of what we mean by quality, right? We want to kind of consider all these different things as we try and understand and rank order these questions, or rank order these answers to these questions. So there's different ways to do this. And again, I'm going to kind of give you a 1,000-view overview of this, right? So Marjo's saying, is there an option to update the model in real time? Yeah, there can be. Yeah, there can be. And oftentimes there is, and we'll talk about that later on for sure. It depends how you set it up. But yeah, a lot of recommendation algorithms are kind of set up that way for sure. Because again, you want to try and get updated information in real time for sure. This is correct. All righty. So again, there's different types of ML formulations, right? So you have this point-wise, you got pair-wise, you got list-wise, okay? And it really kind of just depends on what you're trying to do, okay? And we'll talk about these more in a second, right? But maybe a lot of times what happens with these ranking algorithms is you're trying to predict a score, right? How this score gets predicted, it's really kind of dependent on the model that you use, the algorithm that you're kind of thinking about, how, Quora kind of sets up that state, right? But sometimes you might want to think about, point-wise regression on answers, right? So maybe you have one answer and you're going to try and score it in different buckets. I have a little diagram which I'll show you out here in a second. Maybe pairwise, right? Maybe you have two candidate answers against a question, and you want to try and see which one has a higher score. Maybe list-wise, right? Maybe you have a bunch of different answers, right? Maybe you have 100 different answers for one question, and you want to try and figure out which one is the best, right? So you can try and rank them that way. Okay. Now, how that gets done, it can be very, very dependent on what you're trying to do, right? We'll kind of talk about some ideas here in a second. Whoops. And again, that's kind of what I mean, right? We have our question, we got our answer, and then we have a score, right? So like 0.9, 0.8, 0.5, ideally maybe 1 being the best, or like Quora gold, or 0 being like really bad, right? And we want to try and make a model to kind of score them and be able to kind of regress on that, be able to kind of give a higher score for a better answer combination, okay? Now again, how they do this is very dependent on the model that they're doing, how they set that up. But this is kind of the idea. Again, 1,000-foot view of this, right? We're just trying to give you an idea of how they would do that. So what kind of metrics do you actually care about in this case, right? So there's different things you care about. And it really kind of just depends on the situation. So, I mean, one thing you might care about is something like R squared, right? So ideally you think about this R squared metric, you're trying to think about the proportion of the variation that is explained in your dependent variable from your independent variable, right? Now, ideally, you can add more features and get your R squared higher. So it's got to be kind of balanced to something else, right? So maybe you care about your R squared, or maybe you might care about your MSE or your MAE, things like that. Maybe precision and recall for later on, which I'll talk about if you kind of formulate as a classification problem. There's also some other kinds of metrics that you can care about. Like one, for example, is called a normalized discounted cumulative gain, which is almost like it's used for ranking problems. I usually found, and And it measures the effectiveness of the ranking system. And it's kind of normalized, and you take into account various aspects into a ranked list, right? So you have that list and you almost want to rank them, but normalize them against other items that are inside the list, right? So there's different metrics that we care about. And these are kind of be all like almost offline, right? Which we don't update them in real time. Okay, we kind of just care about them. Maybe we train every Sunday, our big, huge neural net that's going to handle all this on Sunday, but then it's going to get updated. But those metrics on Sunday, these are going to be those offline ones. That's kind of what I mean by that. But maybe about online metrics. What about online metrics, right? So like kind of like real things that we care about, right? So, maybe if we're at Quora, one thing we really care about is kind of like it's a CTR, or it's click-through rate, right? The number of clicks that your ad receives by the number of times your ad is shown. It's something that people really care about, right? Oftentimes companies like, Facebook companies, social media companies, or Reddit, or any kind of companies, they care about trying to get clicks on ads, right? So that might be something they care about. Our number of successful sessions, right? Something that people care about oftentimes, and I don't know, you might notice this too when you're on like Instagram or Facebook or on Quora or on Reddit, right? The longer you are on a particular post or subreddit, well, what happens, right? Well, they actually want you to like, oh, if you really like that data science subreddit, well, I'm going to show you more of the data science subreddit, right? So if you look at Reddit, they kind of update that, right? So you kind of see, oh man, I've seen a lot of data science subreddit posts often, but I'm not seeing something else, right? Well, it's because you're probably on that subreddit a long time. So these kind of things that these kind of companies, internet companies, care about, in particular, somebody like Quora. Okay, so it's kind of the metrics that we care about, online, and we're trying to update. Again, if you're on, a certain post or a certain subreddit, if you're not talking about Quora, you want to update the model to kind of show you those things and just feed them to you, right? Just feed them to you. That way you can be on the app and you can stay on there. So that's really what these companies want. So just some high level architecture we're going to kind of talk about here in a second, right? But you have the ranker, like we talked about. You want to generate your data, right? You actually want to generate the features that are going to go into your model. You actually want to train the model, right, on that training data. And then you want to actually take real-time user behavior to be able to, stream a pipeline of some kind, right? To be able to update things, okay? So it really kind of just depends on what you're trying to do. Ashral is saying, is this considered a supervised or unsupervised problem? It depends. Yeah, that's a great question, man. So it can be supervised, it can be unsupervised. If we're going to be trying to predict those scores, that can probably be a supervised problem, right? You think about like regression. But maybe it can be unsupervised depending on what we're doing. I guess later on, I'll kind of show you some unsupervised techniques. If we're trying to discover patterns in data that's really hard to get labels on. So it can be a mixture of both, and even this whole called semi-supervised learning as well. So it really does vary, but it can be a mixture of both, for sure. Great question. All righty. Oh, and I also see another one here. I believe you are anonymous attendee. Somebody from IK might correct me, but I think you're going to get these slides afterwards. So feel free to correct me, IK. All righty. So to kind of show you some components here of what we're doing, right? So we have different things, and again, this is kind of show y'all just in real time what's happening. So we kind of have this training, right? This training process that goes on. Think about, maybe on Sunday we train our model to take in these answers. We predict on scores. We have other features there, and then we train our model based off of that, right? But then we have user actions, right, that happen in real time, right? And those, it can be upvotes, downvotes, comments, answers, different things like that. We want to take those features out, and we definitely want to make sure we put them into the training data, which is good. We should have that. But at the same time, we want to update those scores in real time, right? So what we can do is we can take it in real time, and we can feed those features into our model and be able to kind of get those scores almost updated in real time, like we mentioned. So we kind of have this almost this kind of like side kind of idea happening like on once a week, and then every single day we want to try and maybe update it, our model to account for new aspects that come in, or new features that come in. Okay, so again, kind of goes back to the whole thing. Like if I was looking at mathematics kind of like group in Quora, but then I start looking at the physics group. Well, Quora's like, whoa, well maybe he likes physics now. Let's go ahead and show him some more physics stuff. Things like that. So we want to make sure that we kind of update that. And that's kind of what we're accounting for here. We've seen all the math already here, but maybe like the physics is popping up here. This kind of idea. So just some training data generation, right? So what kind of goes into this? What kind of data would Quora be looking at, right? So there could be hand labeled data. Think about things like surveys, right? Maybe we have like surveys that Quora wants to give out, right? Maybe they're running an A/B test and they're trying to see, okay, well, which if they kind of just pick you as a user, they're gonna post up a survey. They say, would you be willing to answer this survey, right? And they want to say, how would you rate the quality of this answer, things like that. And that would be rated on a scale between 1 and 10, things like that, right? That might be how they get it. Maybe some logging data, right? That they're trying to get. Advanced labeling, right? So you have this kind of semi-supervised approach where you maybe have like a subset of supervised labels, but they're really hard to get. So you're going to train a model on those labels and then try to make more data based off of those labels, right? So that can also be a big thing. Maybe you're trying to look at buckets, right? Maybe you're trying to do like a multi, classification problem where you have a kind of a low quality, a neutral, and a high quality classification problem, right? So that could also be something you want to try and train on, or a numerical quality score, like a regression, kind of like we talked about. Okay, so there's different kinds of data generation that we can look at, or that they can look at Quora. And again, it really kind of depends on the problem. So if it's for scoring, they might want to look at regression. They're trying to bucket high quality, low quality scores. That's going to go into that bucket, right? So it kind of just depends on the training data in the case. So what kind of user features do we actually care about in our models, right? So what kind of features do we, what kind of features do we care about? So, here's a question. Is semi-supervised same as self-supervised? Kind of, yeah, pretty much. I would say so. Yeah, at least for this. Right. Okay, so user features here, right? So what do we, what kind of features do we care about, right? So we care about time on the platform. Maybe we look at the number of answers, so the upvotes and the downvotes, the number of questions that they maybe have looked at, or they've answered, demographics, comments, shares, are they an expert, so on and so forth, right? So different things to actually consider for the actual user, right? So different things to look at that we actually want to maybe update. Oops, and let me go ahead. There you go. Now, what about answer text, right? What do we actually care about in the answer text features? So again, there's user features, there's answer text features, there's gonna be other things, right? So again, in the answer text that we actually look at, right, this is a lot more where the NLPs come into play, right? Like you have this tokenization methods, or maybe embedding methods, right? Maybe they have their own kind of embeddings that they want to actually look at for their answers. That can also be a big thing. So it's like kind of like applications of NLP in this point, right? You think of like bag of words potentially, or like word to vec, glove, things like that, or maybe something more nuanced like BERT, right? Can be there for features for those answers. Again, upvotes, downvotes, shares of the answer, comments on those answers, formatting. Kind of talked about before, right? The total average time spent on each answer. That's going to be another big thing. Number of words in the answers. This is usually going to be kind of normalized in some way. You don't want it to just like, you don't want to just kind of leave the most short answers or the longer answers to be good. You gotta kind of find that sweet spot, right? If it's too short, like maybe there's a penalty for that, and for the longer answer, almost like another penalty for that, right? So it kind of just depends on what we're looking at there. But there's also like a syntactic complexity of the text, right? So like, is it relevant to what we're answering in the question? But at the same time, like is like, does it make sense, but is it complex enough or nuanced enough to be able to answer the question in full? Okay, so these are kind of the different things they have to care about, and they kind of have to almost like, these are all kind of concepts, and what Quora has to do is almost kind of like numericalize them, right, in some capacity. Like tokenization could be very simple, but how do you normalize or kind of numericalize the syntactic complexity of the text, right? So things like that. So there's different things to consider there. Again, question answer combination features, right? So like total views, high quality views, number of upvotes, downvotes, and is the answer actually answering the question, right? This is kind of the one thing that we're actually going to care about, right? We actually want to see, is the answer actually answering the question that they want to see? And what about labels, right? So other things to kind of consider, right? So generating labels for this large volume of data, that can be pretty tricky. I can imagine, when you're looking at this data, how do you actually rank something as high quality, low quality, mid quality, right? There's a human aspect to that as well. But maybe you might want to look at ratio of upvotes to downvotes, right? That's a good starting point. If something has a lot of really, really big upvotes compared to downvotes, maybe that you might want to rate that as like a high quality answer. Again, it's a baseline, but you might want to try and do that and kind of adjust from there. Maybe you want to try and do things that are highly popular, things like that. You can also try things like a user survey, kind of like we mentioned, right? Like you can actually try and maybe rank things according to that. But again, it's very expensive to scale, right? If just because you show me a survey and I'm on Quora does not mean I'm going to answer, right? So you have to account for that, again, that human kind of aspect to it. So a large volume of that kind of data is going to be tricky to be able to generate. And again, it could be pretty tricky to generate a training data set in that way. So it takes some time to actually kind of generalize that in full scale. And here, kind of show you like an image of what they kind of do here, where you have like your author, you have the answers, and you're trying to rank them according to some capacity, right? And usually, the higher the score is, the better, right? So maybe like this answer again is redacted, obviously just for privacy reasons. But maybe you might have these answers that are really high, be really good, or in green, be really good. However you're ranking it. Maybe the ones in red aren't very good. And you can look at the downvote count and take all this into consideration when trying to rank order these answers for the questions. So you have these kind of different ideas to kind of look at there. So just to kind of show up visually kind of what they're doing. Now, when you think about these models, right, there's different ways to think about them. And that's kind of what we care about, right? Like, how do we actually model this kind of stuff? So for the regression, a lot of the time, what they're doing is usually you want to kind of start with a baseline, right? Like a linear regression, right? Or usually like almost like a gradient boosted tree. And then eventually probably get to the point where it's a neural net. I can imagine for these scoring, a neural net's going to be really useful, but even for classification, it's kind of the same thing. You want that baseline of the logit to maybe try and bucket high quality, medium quality, low quality, things like that. And same thing with like random forest, gradient boosted tree, and again with deep learning, right? So you have like these basic models that we're using, and all of them kind of get used to either kind of numerically score a rank, or maybe kind of bucket an answer into a kind of quality bucket as well. So different things to kind of consider, right? But when you're training these models, one thing you have to really consider. So there's this thing about classification, for example, right? So you have these classification models, right? So let's say, for example, and this is going to be something you think about even outside of Quora, right? But if you're trying to, let's say, bucket an answer into a high quality, low quality, neutral kind of bucket, right? You can do things, or maybe just high quality, low quality. Let's just kind of make it binary for now, right? Well, you have a logit, right? You have a choice, right? You can do something like a logit, you can do something like a tree-based model, right? But there's trade-offs, right? When you try and do that, right? You got tree-based, right? So, or you have a logit, which is actually really nice because it's very simple, it's very fast, it's very interpretable. But oftentimes, when you think about logit, it's predicting, right? It's almost like each feature is kind of it's linear of the other, right? So it's independent of another, and you're pretty much just trying to essentially do a modified linear regression. So you don't really see any interaction in the model with logit, which might not necessarily be a good thing, right? Depending on what you're trying to do. So it's very interpretable, but sometimes you kind of sacrifice that for accuracy. Whereas with the tree-based model, right? You think about a tree-based model, it's really good at being able to interact with features, right? And you actually get a pretty neat accuracy, but it's kind of hard to interpret, right? Like why is the tree making a decision the way it is, right? And again, think about this at scale, right? Think about this at scale. When you think about, I think the big thing where I often see people like in data science when they're trying to break into the field is they think, oh, I have my model on a notebook, right? And it's good to go, right? That's fantastic, that's great. But what about when you're trying to put that model into prod, right? When you're training a model in production, it gets big, it gets crazy, right? Like for example, in my work, I trained a model on over 1 billion records, right? When you're trying to put that in prod, there's a big ML ops component of that, right? Which we actually do teach here at IK, so it's a plug right there, right? But the big thing here, right, kind of like this last bullet point is, you have this, logit, for example, can be really fast with a latency prediction, right? Tree-based models can work as well. And it kind of gets into this whole point of like, okay, well, what about like a gradient boosted tree? So gradient boosted trees, right? Going back to the whole prod thing, right? Gradient boosted trees, they're really awesome. They provide a really, really high quality results for what you're doing, right? They provide a good balance of accuracy, complexity, training, time prediction, a bunch of things, right? And there's pros and cons to each algorithm, right? Maybe y'all have heard of these, right? We have cat boost, you have XGBoost, you have light GBM. right? Different things, and they all have their pros and cons. But again, when you're thinking about this, and this is something that Quora has to think about, you have to think about putting things to prod and what that means, right? So for example, like like what I've seen in my work, like let's say you want to make a prediction, like let's say you're trying to train a model on mostly categorical features, right? Well, if you're doing that, Cat Boost is really great, right? Cat Boost is awesome because it's meant to pretty much, essentially eliminate you having to one-hot encode your categorical variables. It does that for you, right? It's awesome. It's great. Cat Boost is fantastic. I love Cat Boost, especially when you're doing with categorical data. It's awesome, and it can handle categorical and numerical. But the thing that people often forget about Cat Boost, right, is that what Cat Boost does is Cat Boost trains a model. Let's say you're training on 20 million records. It trains it. It doesn't necessarily one-hot encode the features. You can set it to do that, but what it does is target encode. Well, if it target encodes those features, it creates hash tables. Well, the hash tables that you get that gets created inside Cat Boost, it stores them in memory. So it stores them inside your pickle. So that means your pickle or your model can be over 5 gigs large. And then what happens is you run into memory issues when you're trying to put the model into production. I know because it's happened to me and it's happened to my team in prod, right? So Cat Boost is really useful, but you got to think, oh man, I have these other things I have to worry about. And these companies like Quora, when they're dealing with huge chunks of data, they had to think about those things, right? For example, like what if all you really care about is like inference speed, right? Well, XGBoost is really, really cool. But going back to my friend Cat Boost, what makes Cat Boost really nice is that you can pretty much do, Cat Boost makes symmetric trees. So that means you can go from the root to the leaf in almost one straight shot. So because it has those symmetric trees, we're able to go ahead and make really fast inferences, right? So Cat Boost compared to like XGBoost or like GBM can do things really, really quickly. But again, you deal with the memory and training speed. So how do you deal with that? Well, what if you care about training speed the most? Then light GBM might be your best friend. Like right now, I'm actually building out a few models using light GBM because it's really, really quick to train because of the way it doesn't split on the leaves, right? So again, these different algorithms you have to actually kind of consider and different things you have to really think about when you're training your models, especially at a company like Quora, right? If you're going to do a gradient boosted decision tree, try to understand why you're doing that, okay? So different things to kind of consider there. Hopefully, kind of a little bit of a tangent, but it's just a really, really good bullet point right here that I want to try and kind of remind you of, right? Even when you're doing this ranking algorithm, you're trying to predict, good quality, high quality. The amount of data that you're training with and the fact you want to put this in prod does matter because remember, Quora wants to try and update this stuff in real time, right? So inference speed matters, latency matters, right? So are we going to use an XGBoost model? Probably not. Maybe we might want to do Cat Boost. We might have to deal with memory issues. There's ways to control that with Cat Boost now, which is nice. But you have to kind of deal with those things. So that's kind of just some things to kind of nibble on throughout the talk. Okay, that's should be a little cool thing there. I love that stuff. So it's pretty fun. I see you have some questions in the chat, so I'll go ahead and answer them right after we kind of go finish this part right here. So again, just model serving again, kind of like we cared about, right? Latency, it does matter, right? So you definitely want to make sure you're making those predictions in time, especially when you're updating them. You have hundreds of features for hundreds of answers, right? You want to try and make that as small as possible to try and update them. Oftentimes you want to parallelize the computation. You can deal with caching. Usually shallow trees are easier to kind of go through, especially when you're doing things that build out level-wise, because you don't want to have to kind of go down the tree deep, right? Something like Cat Boost, you can just kind of go from the top to the bottom really, really quickly. So just different things to kind of consider when you're trying to build out these models, right? Like it's not just so much as building it, it's actually trying to put it into production. So different things to consider if you're trying to like do that kind of that bucket prediction. And again, just some common questions that you have to think about when ranking, right? So you need to try and understand what we're trying to do. Well, we actually want the model to learn, right? That's another big thing, right? And what's the best way to do that? Do we want it to understand, a score, or do we want it to understand a different multi-categorical bucket? What is it that we want to try and do? That's always the big thing, especially with Quora, right? You want to feature engineer, right? The interpretability of those features is actually really, really important too. Class imbalance is going to be another big thing as well, which we'll talk about later on with other ML use cases. And also the training data is going to be scarce as well. So other things to kind of consider when we're doing these too. Okay, so just common questions that we should really think about, especially as we go and try to build our ranking model. So that's kind of the again general root idea there, y'all. It's going to hopefully try and show y'all kind of a general idea of what's happening there. But different things to kind of consider when you're trying to rank them. That is going to be the big thing. So let's see. So I got some questions here. So So why do we not go with the decision tree? I'm sorry, Ashraf, I might have missed, I think it was from a little bit earlier. If you want to maybe repurpose your question, I can always answer it there. Sorry about that, I might have missed it. Let's see. So Mojan saying, what determines the relevance? So relevance can also can oftentimes just be kind of saying like, is the answer, is it actually answering what the question is asking, right? Maybe there's some semantic similarity between the two, right? That can be kind of a metric we're looking at. The big thing is the content similar? Would be kind of determine relevance there. And is it coherent? Things like that. Let's see, and I'm just saying, how do you do distributed training? So oftentimes with distributed training, this is going to be where Spark comes into play. So you want to try and build out your Spark model. This is going to be a big thing to try and do that. I know what I've done in my work has been building out distributed tree models using Spark. Now, doing it with Spark can be hit or miss, just because it can be kind of finicky. It's getting a little bit better, but oftentimes if I'm on Databricks, it's kind of where I'm doing it. So you definitely want to do it with Spark. Let's see, so Ashal saying, it seems like a ranking problem on search run on revised index databases. Let's see, oops, I think I missed, okay, there you go. Based on currently asked questions, or does it have to all the questions as previously linked and ranker just bubbles the best at the top? So it seems like a ranking problem on search run. Does Quora generate ranked results based on currently asked questions? Oh yeah, so it's kind of a mixture of both, actually. Yeah. So you kind of have what's already been asked, but then you also kind of have this new information that's being fed into it. Yeah, so it's kind of doing both. Yeah, so it's kind of taking what's already been seen, what's currently seen, and kind of mixing them to kind of provide the best answers to the top. So, and Ashraf saying, does Taboo suffer from target leakage then, since you mentioned this target encoding? Not necessarily. No, it shouldn't. No. As long as you split your train data correctly, because with it's going to one-hot encode them for you, right? So it shouldn't necessarily have any leakage on that target, assuming you split your data up correctly. So should be good to go there. Let's see. Can my data set generate with these? Yeah, I think so. Savish, we can maybe talk about that for sure. There's different data sets that do this. Oftentimes, we try to, Quora kind of makes these data sets proprietary, but I believe we have some that we can kind of maybe show you, point in the right direction. Can we use feature selection techniques to select relevant features? Yeah, man, of course. Yeah, definitely. There's different things you can try and do. Depends what you're trying to do. Maybe for your regression, you want to try and do a lasso, because again, these features can be really, really long. If you're dealing with a really sparse matrix, maybe something like lasso might help you, or like a chi-squared, non-parametric test, things like that. So that can also help as well with doing your feature selection, without a doubt. So all those kind of fundamental ML kind of things that do come into play, for sure. All righty, y'all. Great question. So I want to try and be respectful of y'all's time. So I'll try and kind of go through these next few things really quickly. A lot of it we kind of already talked about, but I just want to kind of dive into a little bit more, right? So what are the other ML problems that you see at Quora, not just at Quora, but also you see and other kind of social media platforms, right? So there's different things, right? There's this thing called feed ranking, right? I think I've already talked about it, right? Think about like something like Instagram, right? If you're on Instagram, let's say you want to see a bunch of pictures of reels of cats or dogs, whatever you're interested in. Facebook wants you to be on the app for as much as possible, right? So they're gonna keep showing you pictures of dogs and cats. We need to try and update that as much as possible, right? Quora does a very similar thing. Yeah, and duplicate questions, right? So maybe this is really like almost like a semantic similarity thing, right? We don't want too many questions being very similar, right? Because if two questions are on the platform already, like for example, if someone says, what is the bias variance trade-off in machine learning? And somebody else says, I want to know more about the bias variance trade-off in machine learning. Can anybody help me? Right? Those two questions are really asking the same thing. So we want to almost kind of merge them together, right? Or maybe if one's already has an established answer and this other person asks it, maybe we want to kind of almost like take this one off so that people can kind of see this new one, right? Different things like that. So we want to kind of remove those duplicates. Another big thing is moderation, right? Again, this is a big thing that a lot of social media companies deal with. It's not just Quora, right? Think about like Twitter or Instagram, things like that. You always want to try and remove malicious content, right? And this isn't just text. This is image. This is this can be sounds, things like that, right? So we'll talk about this more in a second. If anybody's interested, I can kind of point you on a good resource for this too. But this is something else to really kind of think about, as well as topic expertise detection, right? So, if someone says that they are an expert in, I don't know, dog sitting, you want to make sure they're an expert in dog sitting, right? Things like that. So pretty much trying to just understand those things. Okay, we'll kind of go into each one individually, and I'll try and get us done in the next few minutes. So again, kind of the newsfeed, again, we talked about already, right? So you go onto the Quora website, this is essentially what you're seeing. You have an updated list of questions and answers. Again, it's kind of like Reddit, right? You have a bunch of different question answers. Well, in Reddit's from like subreddits, it's a little bit different, but you kind of have a bunch of like groups that you may be part of, some people you follow, things like that. And they always want to kind of show you those certain people. So if you really like Andrew Ng, you want to make sure you kind of follow him on Quora, wherever he responds to things, you want to make sure you see his stuff. Quora wants to make sure you see that because it's relevant towards you, right? So how do they actually go about doing that? Again, questions can include photos, videos, links, again, to all these different things, right? You have to start thinking about that, right? Because again, they can include photos. So again, this is an internet, right? So anybody can go on here. You want to make sure you, again, moderate it. That's another big thing's going to come up, right? Groups, people spaces, comments, things like that can pop up. So again, and they want to make sure this is always updated for the person that they're actually showing this to. So again, it's kind of like a problem statement, right? You have a user and they're on Quora and you want to essentially show them their network of the things that they care about, right? So, what's kind of the best way to do that? And it's very similar to what we've kind of already seen before, okay? So different requirements that we care about, right? So again, the newsfeed based on posts from people's pages that we follow, right? Kind of like a typical thing. If we're following Andrew Ng, we want to see stuff from Andrew Ng. If we're following Andre Karpathy, we want to make sure we follow Andre Karpathy, right? Things like that. So Quora wants to kind of show us the information that we're actually following. And here's the thing though, right? If anybody is on Instagram, again, I'm trying to show you how like often this is a kind of a common thing that a lot of internet companies deal with, right? If you are following 2,000 people on Instagram, how do we actually kind of rank order which kind of what to put on your feed, right? There has to be a relevance there, right? Same thing with Quora, right? If you're following 2,000 people, how do they know which one to show you, right? These are things we have to kind of consider. But again, feeds can contain images, videos, and text. So how do we kind of take that into consideration? And again, new posts, right? How do we actually, what do we do with new posts, right? The baseline system is going to be to just rank things chronologically, right? Like, why not? If things are ranked chronologically, let's just go ahead and say, here's the newest thing, let's just kind of put it up there, right? But just because it's new doesn't necessarily mean it's relevant, right? To you, right? So you almost need like an ML system, not necessarily a baseline, but you want a feed that kind of ranks, not just based off of chronological information, but also based off of relevance, right? Based off of things that you think are important as well, right? Are relevant to you, okay? So things like that. So if I'm following, a cat page on Instagram, they post a picture of a cat. Maybe I don't care about seeing the cats today. I want to see pictures of dogs. So maybe the dog post that got posted, 2 hours ago, that, I want to see that one first. Things like that. That's kind of what we care about. But again, just non-functional requirements that we should actually see, right? So again, this should be happening in real time, guys. Remember I talked about before, right? We want to be able to do things in real time. So maximum latency, we should be reducing that as much as possible. That's going to be a big thing. A post shouldn't take more than like 5 seconds or whatever threshold we're looking at to make it into a user's feed. Okay, so it should be happening very, very quickly. We want to definitely lower that as much as possible. And I think this is really a really interesting kind of, I think these next couple of slides are really kind of show you this, right? So if you look at I kind of want to show you the size of this, right? So, if you have 300, million active users, right? And on average, each user sees 40 activities per visit, right? Each user visits the site 10 times per month, right? It's a ton of observations you have to actually look at, right? So your data size is huge. So you have to be able to support, all of these 300 million users in some way, right? So it kind of gets to this, right? So if the average user kind of follows, 300 people and 200 pages, right? Assuming we have these 300 million daily active users, which is crazy, right? It's a bunch of different people and they're trying to fetch their timeline in real time, right? And they try to do it 5 times a day. Well, that means we need about 1.5 billion newsfeed requests per day, right? or approximately about 17,000 requests per second. That's huge, right? So I'm trying to show y'all like in real time, this is kind of what Quora has to deal with, right? So these models have got to be quick, right? They have to be fast on what they're building. These neural net models that they build out, or these boosted tree models that they build out, they have to be able to adjust things on the fly. Okay. And this is why big companies, why they're actually in the cloud, right? So that's why they're using things like Azure or GCP or AWS to be able to store this data. Because if you think about their storage estimates, right? They have 500 posts in every user's feed. They want to keep it in memory, for a certain amount of time, for a quick fetch, right? Because if maybe the content that I viewed 5 days ago is still important to me, or maybe 10 days ago is still important to me, they want to make sure to keep that in size. But if each post is about 1 kilobyte, kind of 1 kilobyte in size, right? You need to store about 500 kilobytes of data per user. Well, that means that for all active users on the platform, you need 150 terabytes of memory, right? So this thing is humongous, right? So if you need 100 gigabytes, if each server can hold 100 gigabytes, you need about 1,500 machines, right? And this is why nowadays, at least modern day platforms, on-prem kind of services are almost falling to the wayside. Data is becoming bigger and bigger and bigger, especially at these big companies, internet companies, and it's almost unfeasible to hold this on-prem. Like you need the cloud to be able to do things like this. So hopefully this kind of shows y'all, right? Like in order to do things like this, right? In order to update this feed in real time, right? Data in the wild, y'all, is a different animal. It is not just some CSV that you're going to see. It is humongous. It is big. It is unwieldy, right? And hopefully it kind of gives y'all some kind of context for what's kind of going on there. So just something to keep in mind there. And again, it could be stored on this too, potentially. But usually it's going to be in the cloud, so it's going to be a little bit different. But just kind of give you some ideas there. So again, just the type of activities to kind of think about when you're on Quora, right? So you have the clicks, you have the up votes, you have the down votes, you have the shares, expand, right? All these different things that somebody is doing on there is going to influence the feed, right? If you want to share it, if you want to comment on it, you want to click on it, follow it, follow the person, things like that. All these things are going to matter. So just different things that kind of go into the algorithm to kind of rank things are going to be what we care about. So model selection, what do we actually care about when we do that, right? So the big thing, like I said before, right, this data that they're going to be training to be able to rank order the algorithm or to rank order your feed is going to vary, right? Now, how each company does a rank ordering is going to depend, right? So people like Twitter might do something a little bit different than like TikTok, right? The cool thing about those companies is that they've actually open sourced their recommendation algorithms out, which is pretty cool. So if you're interested in kind of seeing that, I know Twitter and TikTok have open sourced it. TikTok has done a variation of their recommendation algorithm, but it's all up there that you can actually do, which is pretty cool. But again, regardless of whatever recommendation algorithm you're looking at, it's got to handle large amounts of data. It's got to be personalized and it's got to be fresh, right? So because it's handling this large amount of data, right, that means is you usually need some type of distributed training model. Now, how you do that can vary from company to company. So what I've done in my personal experience has been like to look at things on Spark. Things like neural nets can be parallelized on GPUs nowadays, so that's something that can also be done as well. But this kind of distributed network of setting, this is kind of what needs to be done. It's kind of almost like the new shift of data science is doing things at scale like this. Because it's not, again, like nowadays there's so much data, especially at these big companies. So you really have to care about. But the big thing that you have to think about too when you're training these models in these large amounts of data is inference, right? So these models can be big when they're trained, but they have to be able to make predictions really, really fast. And this is something where Spark is still struggling with, I'm being completely honest, at least in my experience. And this is kind of why deep learning in like distributed settings definitely does help out a ton. So just something to kind of nibble on with that, okay? And again, different ranking algorithms can be kind of vary from company to company. Like I said, Twitter and TikTok have actually made those algorithms open source. So you can kind of dive into the nitty-gritty there if you're interested. And again, kind of we talked about before with the training and the inference, right? So you have this training process, we have the feature pipelines. They're going to go into what's called a feature store. Think about a feature store as almost kind of like a gold table. There's a bunch of data that's ready, it's been processed, it's been cleaned. It has our features ready to go. There's literally nothing else that needs to be done to them except pass them into the model and train them, right? Again, think about this happens once a month or once a week, right? And then we kind of have an inference time. We need to be able to take that training. We have a model store. We have an item store. We're going to put them into our feed service. We have our client, kind of our user who's on the website, kind of interacting with the application. And the model on the back end is kind of interacting with the new data and trying to update that feed in real time to try and give the user or the client the best experience on the website. So again, this is a very common thing that happens in other social media platforms. And they're again, the big thing is to always get the most fresh data as quick as possible in a unified way. So something to kind of think about there. And before I go into this next section, these next 3 sections we should knock out real quick. Let's see. All right, so let's see. So let's just say, can you point us towards some ML models for anomaly detection in small data sets, such as error data and IP distributors? Oh yeah, great question, man. So it kind of depends. So if it's a small data set, oftentimes, so it depends if it's unsupervised or unsupervised. And I've done a lot with anomaly detection. Usually for me, if it's unsupervised, a lot of things that I like to do are like PCA, UMAP, TSNE, pretty much just take that data, try and project it down onto some subspace that explains the variation in your data, and then try and recreate the data, or try and recreate new data and see if what the model predicted and what you actually was there, if that difference, if that anomaly score difference is big enough to warrant an anomaly, right? This is the way I have done it, right? You kind of take what the model predicted, what was actually there, you look at the difference and you try and see, is it within some range? So something like that might be really good, especially on data sets like that. And those models actually do work for supervised methods as well, especially something like PCA. Something low level, something really simple like that, or something that's really good to do in that situation. Something like gradient boosted trees, especially when you're trying to predict a really small target or overbalanced target, can be really tricky, mainly because it can overtrain. The recall is not going to be very good because you have like a small target. So in that case, it might not be the best. I've seen it kind of work. It depends on what metrics you're looking at. But usually things like the PCA, UMAP, TSNE, that's kind of where I go, or my first idea for anomaly detection. So something to think about there. Washoff saying, how do we ensure that we are doing better than random for a given question, some more A/B testing? So it depends on the model, right? So if you're doing stuff at random, you usually have a baseline that you're looking at. Maybe you're seeing 20% high quality, right, in your classification algorithm. You want to make sure that your algorithm is at least doing better than that, right? Maybe that might be it. Now, whether you get those labels, that can be A/B testing potentially. That can be a thing. But usually there's going to be some baseline that you get from the labels, and you want to just try and see, are you doing better than that coordinated baseline? And I believe the slide should be available to y'all for sure. Okay, so I got that one done. All right. Let's see. Do you use the inbuilt ML algorithms built in Spark framework for training, or do you use Scala? Oh, that's a great question, man. Yeah, so I've done both. Yeah, I've done both. In my personal work, I've done both. The ones built in Spark are good. They're really slow when they're training. It depends on how many workers and clusters you have. But things like XGBoost and CatBoost have actually made their own Spark versions available to actually go in and work actually on there, which is actually really cool. So they're fixing things up. It's still it's still becoming better. They're still modifying things as we go. But these, I'm not sure about LightGBM, but for sure XGBoost and CatBoost have made their own Spark versions of this. Scala, I have done some stuff with Scala. I've done like a Word2Vec in Scala. Just I think it was a little bit easier to set up at the time. Usually for Scala, I'm doing a lot more data engineering stuff with it, but it can be done as well. So definitely Scala, Spark, it can be very useful for sure. Let's see. So let's just say PCA UMAP. The third one was TSNE. So T and then hyphen SNE. So something to look there as well. So, alrighty, so I do want to make sure I get you out of here in time. So let me kind of get these next few questions. Suresh, I'll make sure I answer your question here in a second. Okay. So again, duplicate questions, right? What do we want to care about? I should go knock out these next few slides here really quickly for us. Just again, right? If you have different questions like this, right? They all are pretty much saying the same thing, right? You want to try and just say, can this all be condensed into one question, right? We don't want very valuable answers kind of getting redistributed to different questions. So how can we kind of put them into one spot for them to be used? So that's kind of why we don't want duplicate questions, right? And how we detect them can vary. But ideally, what I usually think about with duplicate questions is more like semantic similarity, right? So you have these different questions and you're trying to understand, okay, semantically, are these two the same thing? And one way to do that is going to be to look at something like a sentence transformer, right? You take each of these sentences, you transform them into an embedding, and you're trying to see, okay, are these embeddings similar to each other in some capacity, in some way? How similar do they need to be in order for them to be determined to be essentially the same thing? Things like that. There's other ways of doing it. That should be kind of a way that would be probably the quickest. Now, if you have targets that you can actually predict on, that's really awesome. Maybe you can do like pairwise targeting. That's something that Quora can do as well. But again, this is something that we care about, right? We want to try and remove those duplicate questions. The thing is, when you do the semantic similarity, again, it's quadratic in nature, right? So you have to check, what is the sun's temperature with how hot does the sun get, how average temperature of the sun, you have to do these pairwise matches, and the number of matches that you have to do can get really, really large. So something to think about there as well. Again, I kind of went through this already, but there's different approaches, right? Maybe you have pairs of questions which are similar. Maybe you have them tagged already. You want to try and do a binary problem to make sure that they're the same thing. Maybe you have a kind of semantic similarity that you're trying to do as well, kind of like I talked about with like sentence transformers or BERT, things like that. They're kind of big, like LLMs. Things like that are what kind of come up as well. So just trying to get us to the next few slides here. So moderation as well. This is another big thing we have to take into account. So again, what we really care about here is we want to make sure we're eliminating hate speech. We're eliminating things like, adult content maybe on the site, things that we don't want on there, fake names, impersonation, all these bad things we don't want on there, right? We want to try and eliminate it. And there's different ways to do it, right? So for example, like I told y'all, Twitter actually made their algorithm, their moderation algorithm public. It's on GitHub. You can look at it. And a lot of that's done just through basic CNNs to detect images that are bad, things like that. But regardless, whenever they're making these predictions, right, either at Twitter or at Quora, the big thing that you're going to notice is it's severely imbalanced, right? So the number of bad labels to good labels is going to be very large, right? So you may only have a 1% target of bad labels, right? So how do you actually deal with that? So in terms of like precision and recall, right? Your recall is not going to be very, very good, right? So you may not be able to find like all of the bad labels, but the one that you predict on, you need to make sure that they're actually correct, right? Because you don't want to you don't want to remove an answer that could potentially be very useful just because your model said it wasn't correct, right? So usually you care about like a low recall if you have higher precisions in this case, right? Again, this is where the metrics really come into play, right? You want to essentially make these algorithms, these CNNs, to be able to detect that bad content very effectively. So the predictions that they do make are extremely accurate. So again, if you're interested in kind of seeing like the code for something like this, again, Twitter has actually made that repo public if you're interested in viewing that. That's actually really, really cool. So again, it can be very similar to any kind of internet company. They kind of do very similar things. But again, you have ideally here you want to maybe oversample the minority class. You have high feature dimensionality, so you want to try and reduce number of features down. Again, the big thing is to try and increase that precision as much as possible. Okay. All right, and our last couple slides here, just topic expertise as well. The big thing here is you want to try and make sure that someone is truly an expert, right? So this is something that Quora does as well. So you kind of want to look at maybe their biography, things like that. Again, just to make it more trustworthy into your algorithm, right? You want to try and make sure that all the experts on there are really truly experts. So are they providing relevant credentials, right? Are they listing the specific topics that they are actually experts on, right? Things like that. Are the answers that they're given, are they usually very coherent? Things like that. So again, different things to kind of look at when you're looking at topic expertise into those models. And again, it kind of just depends, right? So if you're looking at like a degree of expertise in machine learning, right? Like maybe someone who's just learning machine programming, maybe they're just learning Python. They might not be the biggest expert. Maybe that increases if you're taking undergraduate courses, or maybe if you're an ML engineer at Quora, if you're a researcher, or if you invented AdaBoost, you might be pretty darn good at boosted trees, right? So all these different things are what they kind of care about to kind of detect these topics, right? It's kind of what they're actually saying, what these kind of implicit meanings, or what these implicit kind of definitions they give to themselves actually mean. So different things that we care about there. Again, just looking at different things to understand this, right? So again, multi-class classification, understanding the text. Maybe they might want to try and understand, the sentiment in that text, understanding what it means there. If that data is labeled, they might want to try and do some binary or multi-classification to say if they are an expert or not an expert, things like that. Various trees can be done here, right? The big thing kind of to think about these, y'all, when you're looking at these recommendation algorithms, is that it's not just one model, right? Usually these algorithms are built up of a bunch of different models. And I think hopefully you're kind of seeing that, right? Like, we have this whole feed thing, but it's built off of this moderation. It's built off of topic expertise. It's built off of, like the duplicate questions, right? It's a big, huge product. There's a bunch of smaller little products. And each of those little products, one could be like a, convolutional neural net, another can be a graded lucid tree. Kind of just depends on there. And that's why these companies have big data science teams. They have one data science team managing that one product, right? And things like that. So again, different things to kind of think about there. Like potentially each topic we just talked about here, they can each have their own kind of team attached to them. So I know over time here, so I'll kind of go to this last couple of slides here really quickly. But again, just trying to understand, like for example, is Andrew an expert? Are the answers upvoted by him? Are they really good? Does he upvote answers, right? If he upvotes answers, that probably means that answer is really good. So we care about that as a particular feature in our model, right? So you kind of have like this transitive property of expertise, right? So if I trust Andrew and Andrew trusts somebody else, maybe that somebody else that he trusts is really, really good. Or maybe I can trust that person, right? So that's kind of what we mean by that, right? It kind of propagates through that network. And there's different algorithms to detect this, right? So for example, you have something like Google's PageRank, which can try and understand, like PageRank is pretty much, if you go on Google and you look up light GBM, Google's going to try and rank the relevant features on there, the relevant websites for light GBM, right? Maybe the first one that's going to show you is going to be the actual documentation for light GBM. But the next one is going to be maybe a Stack Overflow question, or maybe it's going to be a Quora question, right? So similarly kind of applies here at the top with the experts, right? And also the thing called graphical neural nets, something, we actually do learn here at IK, trying to understand how things propagate through a graph, right? Like if I trust somebody else, is there a dependency between us, right? So things like that are different kind of algorithms that we can look at when looking at these things. And last slide here, just again, different ensembles, right? There's different models trained on different types of data. There can be some unsupervised approaches, some semi-supervised approaches, supervised. And we pretty much want to try and combine all of them to kind of get the best idea for what it means to be an actual expert, right? And it really just depends on the data, what's in the biography, things like that, but you can combine them to essentially get your overall, topic expertise person on there. So I know what we're talking about, so I don't want to take too much of Soham's time, but thank you so much for your time. Really do appreciate it. It's been a pleasure getting to talk with y'all. And yeah, it's been tons of fun. So I really appreciate it. Thank you so much.
Andrew, that was fantastic. I learned quite a bit out of it as well. Not that I'm any fancy expert, but still I learned quite a bit out of it. And thank you for talking through all the way for like hour and 5 minutes. It takes a lot of energy. Thank you for putting together those slides as well. And you're right. Anybody needs slides, just let us know, and we'll be happy to share the slides. Andrew is happy. We're happy. No issues on that. Again, Andrew, thank you for doing this. I think it was very valuable. I think it opened up interesting ideas for thinking. I also realized a simple looking thing from outside can be so complex with an inside. Just simply expertise detection, it just can be mind-boggling to just solve. And there is like, it's endless. You could be spending 5 years on expertise detection as a team, and you would still not get to a point where you'll be like, nah, this is done. No, it's never done. It's just like, just continue to improve. And that is something that I've realized as well. Like with even with prompt engineering and anything slightly more fine-tuning, like as models improve and the techniques are better understood, I think we just have to update our knowledge all the time, right? Like every 3 months, 6 months, even the prompting changes. It's just quite a thing for it. So Awesome. No, anyway, I can go on and on as well. But thanks again, Andrew. Appreciate it. Thanks everyone for coming in. Like I said earlier, please feel free to join our webinars if you would like, if you're interested in any of our AI courses. Right. Okay. Thank you all very much. Bye. Have a good night.